All right, welcome back to my operating system hacking and development environment. Today, I'm going to be working on a menubar clock, sort of like the one you see here in GNOME. I'm going to show you what that would look like in here. So currently, I have a clock app that's just an GUI application, and then I have the global menu bar up here up top, but I don't have a clock in the top right corner, which I really would like to have. So the way that this currently works is that the menu bar up here is rendered by the Windows server, and specifically the window manager class inside the Windows server. Um, it manages this area up here, and then user space client applications sort of negotiate with the Windows server to tell it what kind of menus it wants to put up there. But the clock, I'm going to be implementing the clock inside of the Windows server. So let's go ahead and have a look at that. So let's see, first things first, WS, nothing is working. Did I mess up my file system perhaps? Yeah, okay, so let's just do find.name or name.h. Yes, identity.files. Okay, WS window manager. Yeah, so this is where we want to be, and we should go into draw menu bar. Is that the guy? Yeah. So this code here will run every time we update the menu bar. And it's just like really straightforward. Fill it back with gray, draw a nice little line at the bottom of it for that look, and then go through the menu bar menu items and draw them one by one, their text. So then I figure just at the end here, we will do something like back painter, draw text, and we can say menu bar rect, text alignment, center right, and we want to make one of those, what the heck's it called, struct TM. How do we get that code? I'm just wondering, like, how do we do that in the kernel? Let's see what the clock widget does. Calls local time. Oh man, all of this stuff is in the all of this stuff is in libc actually. So I won't be able to call that from the Windows server. That's a bit sad, but okay, so let's just start out with putting the Unix timestamp up there just to see that we're putting everything in the right place, and then we can print it later. What's the next argument? Oh, shit, I forgot the thing already. Let's say string time text. ITC now. Yeah, that's okay. And then and color black, I guess. And I don't have RTC here, obviously. I would like to have a way to get to the top of the thing. Ah. Okay, anyways. Include kernel RTC. Okay. Okay. That's pretty cool. We should put a little offset from. I should have a little padding on the right, I think. Um, Padding. No, text that thing called menu bar. WS window manager. Try menu bar rect. Rect in menu bar. I wonder where I set up the rects in the menu bar. Blah blah blah. Here is where we compute everything. It's menu margin. Okay. Okay. Um, so let's go ahead and make that a member function so that we can call it from elsewhere. Menu margin. Menu bar, menu margin. 16. Okay, and then here we just say menu bar. Menu bar, menu margin, const. Okay, it's fine. And RTC was here, and we will just say translated minus menu bar, menu margin, divided by 2, call 0, and like that. Yeah. I'll put us a little bit of a distance from the edge. Same distance as over there. It's pretty cute, no? Yeah. And what else? Okay, so then we're going to want to have something more pretty here. So I think that we could just get the local time from the CMOS. Because this is what the kernel does. Just asks the CMOS memory for the current time, which is then updated automatically by the real-time clock chip. But this isn't going to take time zone into account, but I'm not sure that time zones is something I really care about right now. Of course, it's always nice to make something more robust. I think for the time being, I'm just not going to care. So I'm just going to go ahead and add some accessors for this. Say like, how about we just just do something like void read RTC read registers. Okay, and setting inside. Inside day. Yeah, and then we can just put these up there. In fact, this should also have been up there, and I guess we can do something like we can put this here too. Year, month, day, hour, minute, second. All right. And then we just do like this. Okay. And in RTC.h, we just add this guy. And then we do the same thing here. And that makes it so that we can just do yeah, maybe I just do like that, and we say hour, minute, second. Okay, and then we're gonna put that namespace there. Okay. Let's have a look. All right, that's pretty good. Maybe we should put the whole thing. Since we're doing it anyway, I mean, I put 2 spaces maybe? Yeah. Year, month, day. Kind of neat when we're getting it directly from the real-time clock. Okay, look at that. It's beautiful. But now, what happens if we turn off the clock? Aha. So it no longer updates unless I move the mouse around or somehow interact with the computer, or if I make the computer generate something that causes the Windows server to wake up. So we're going to want to make the Windows server wake up by itself so that it can redraw the time. So we're going to need to do something in the WS message loop. We're going to need to have some sort of a timer that wakes us up every now and then. Currently, I don't have anything like that, but I would like to have something like that. So I think I'm just going to go ahead and add some event loop timers to the WS message loop. And I figure I would do that by, yeah, maybe something like, what would be a good API? WS, let's just say int timer, create timer, start timer, milliseconds, and int stop timer. Okay, that's cool. And then we'll put here, we'll put something like hash map int footer timer and loop timer. Okay. Wait, no, let's just call it timer. It doesn't matter. And I'm gonna say timers. And I need hash map for that. Okay, and then timer should be a struct timer that let's put the timer ID in there so that he knows who he is. And I guess like a callback. Function. Okay, I need that too. AK function. Okay, and interval and let's see. I guess the next fire time. So wait, what facilities do we have to even get this stuff? We have get time of day. Which will do this. This is kind of hackish, but it will work. Yeah, so we can just do a get time of day actually. Struct timeout. Next fire time. Will it build? I wonder. Yes, I have all the components. Okay. And then in WS Window Manager, we can say, I'm just gonna like set everything up before I implement it, so that it sort of has everything I want. Let's say WS message loop, start timer. Let's update every 300 milliseconds. Probably that's good enough, and that should work sort of like this. We will invalidate the menu bar rect. Okay. And the start timer should take a function. Let's do like that. Okay. Yep. Okay, and then let's go and look at WS message loop and see if we can add all this gunk here. Start timer. Okay. We'll make the timer object. Right, we want to return int. And I guess we should have an like int m next timer ID. Let's just start like that, and then we can keep incrementing that. And next timer ID plus plus timer. Member reference base is not a structure union. Why not? I don't know why it's like that. I'm missing something. Okay, why I am blind. Why am I blind? Member reference base type. Oh, like that. Yeah, this confuses me sometimes. I would actually kind of like it if I could do this, because it would parallel being able to do like new timer, but alas, I have to use the parens. Okay. C++, I love C++ so much, but it really does have a few things that I wish I could do just for aesthetics. Same thing, I really wish I could have a way to turn these into dots, just somehow, if I could just tell the compiler that I know that this is a non-null after this point here or whatever, and then I would be able to use dots after that point. I don't know. I don't know how it would work, but I would like to have that. I've been wanting that for so long because I don't like to look at these arrows. But I digress. Or I don't digress, but I'm trying to do something. Timer, next fire time. And that, my friend, so let's do string time val now. And we'll do this time of day. How do we do this? Now, I guess we do it like this. Now, plus interval now dot tv sec interval divided by 1,000. And the next one is tv usec plus interval percent 1,000. Does that make sense? It wasn't called interval, it was called ms. I'm just going to call it interval instead. I guess that's fine. And then I think that that's okay. We can just do m timers set timer ID return timer ID. Okay, cool. On WS message loop stop timer. Let's go find it. Return. I don't know. I mean, I'm not making a kernel API here. I'm just making some helpers. So it doesn't need to be fancy. Timers remove IT. All right, cool. And I think that it would be good to actually put this thing into a helper called something maybe like message loop timer reload. Yeah, because then we can call that elsewhere. So we're going to do like timer reload, that. Let's see. Okay. Then in the wait for message. So currently we only want select here to wait for as long as necessary, right? This is very similar to the event loop in the GUI library. It actually works extremely much the same. I guess I'm sort of re-implementing that libGUI functionality inside the kernel right now. Timers is empty. Yeah. Timeout. Okay, and then let's say for auto. Oh, hold on. IT value. Yeah, so I'm gonna want the same thing here. Timer dot Um, oh, like that. Okay, or otherwise, if timer next fire time. It's so frustrating that you don't have operator less than on these guys. I guess I could just add that actually. Like, why the hell not? Or am I gonna regret this? Mm, oh, well, I'm just gonna confuse myself if I do that, so let's not do that. Tsec is greater than. Usec is greater. Okay. Times time next fire time. Great. Okay. And then after we return from select, we have to look at all the timers if we have any. I can do like this. Time val now 6 get time of day now, and then we just have to check if this timer has fired, and we do that by checking if now tsec is greater than, or time. So if we have passed that time, then we would do a timer dot callback. Okay. Let's go ahead and automatically turn off the clock process actually so that it doesn't even spawn. And look at that, it's automatically updating. First try. I gotta say, working on this OS stuff, it's really making me better at writing things that work earlier. Of course, it's very, 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 very intense here, so it has bugs, but at least it compiled, and I got carried away there, saying that I got better at doing things that work correctly on first try. Look at that. The quicker you get proud, the quicker you fall. So why is this constantly looping? Obviously, it's because we don't reload the timer when it actually fires. So let's go ahead and do that, because we don't want it to fire again right away. Otherwise, it's just going to fire right away again in the next event loop iteration. Yeah, that's a bit more reasonable. Wow, isn't that cute? We got our very own menu bar timer. I'm pretty happy with that, actually. Um, and maybe in the future um, I will get the time somehow differently for the time zone stuff. But right now it's fine using the real-time clock chip. I don't care that much. I just want to see what time it is right now. Um, so yeah, I think I'm gonna be happy with the video here. Um, so actually, I'm gonna be happy with the code here, but I'm also gonna look through the code before I'm happy with the video. So let's see. First thing we have here, yeah, right. So separating out the RTC stuff so that you can get all the individual clock registers. And don't start the clock app by default anymore since we don't need it. Um, in fact, we can just get rid of that altogether because I don't think I want the clock app at all anymore now that I have it in such a good place. Okay. Mm-hmm. Mm-hmm. Okay, so reloading a timer. That's cool. Um, we didn't end up actually using these timer IDs for anything, but I have a feeling that I'm going to want these later for something. And I like this sort of ID-based system where the client doesn't need to have anything other than like an int to refer to the managed object here. Um, but yeah, so that's just a basic start stop timer functionality. And then here at the start of the event loop, we check if there's any timer that has a upcoming fire time, then we set that to this timeout. And the timeout, of course, is what we're passing to the select syscall, which will make it return earlier. If nothing turns up on the file descriptors, but the timeout gets hit. And then after we return from select, then we look through all of our timers, check if any of them are due to fire. And if so, we just fire them and call the callback and then reload the timer. So like one thing I could do here is that like you could imagine putting the get time of day inside of the loop so that if you have multiple timers and one of them has like a callback that takes some time, you could imagine that you would like refetch the current time at the head of the loop here so that like a subsequent timer, after one timer callback takes some time, subsequent timers would like refetch the current time so that they might fire immediately instead of on the next event loop iteration. But I'm just going to leave it here for now because I think that's okay for this code. Besides, I only have one timer, so uh, it's not really a concern what happens with multiple timers right now. And yeah, and here's the data structure for the timers. Timers go in a hash map, indexed by ID. That's cool. And of course, here's what we actually do when the timer fires. We invalidate the menubar rect, which is like the 16 pixels tall rect on top of the screen. Yeah, put the menu margin, which is like the distance between each of the menu bar items in the menu. In the menu bar, I mean. Right, so this is just updating the old code to call the helper function instead. And this is where we create the beautiful text that we and render it to the top right corner, and that's that helper prototype. Okay. So I think that's cool. Let's just make a commit and say Windows Server, put a clock in the right corner of the menu bar. Top right corner of the screen. Now, this way we don't even need the clock app anymore. Very cool. All right, so I think that is going to be the end of today's video. Let's just go look at it one more time. Isn't it beautiful? Um, so, um, if you made it this far, then I thank you so much for watching, and I hope you saw something interesting. And I'll see you next time.